Aerophones, and there's a book, Fundamental of Musical Acoustics. It could be interesting, and some notes, lectures about saxophones, classification of musical instruments. So I'm going to talk about aerophones. There's a definition here: woodwind instruments, wind, woodwind, and aerophones. Yeah, I think the common concept is aerophone. Single-reeded aerophones with keys, saxophones also. Okay, Hornsted sax classifications: idiophones, membranophones, chordophones, aerophones, and electrophones. And now it's going to be aerophones. The definition of an aerophone: any of a class of musical instruments such as a trumpet or flute in which sound is generated by air as a primary vibrating medium, as a flutes and trumpets. Saxophones are the sound are made by the reed, generated by the reed. So, but it can be a little bit confusing. A black box model of aerophone. There can be energy, oscillation, edge blow, like in a flute, reeds, like clarinets and saxophones, lips, brass, trumpets, for instance, and resonators. They could be closed cylinders, open cylinders, cone, or none of them. Modifier, tone holes, pistons, slides. Can also be a trombone. Then we have a traveling wave in a tube. The acoustic wave in a tube travels through a longitudinal motion, at speed of sound of air, 344 meters per second at 21 degrees Celsius. And c, the speed is this formula, the square root of this formula here. Lambda is a adiabatic constant, is 1.4 for air. P is atmospheric pressure, same as 101 kilopascal, or same as 1000 pascal. Rho is the air density, is 1.2 something. I forgot the entities. Something about 1.2. Yeah. T is the temperature in degrees. So, yeah, I continue. The standing waves, resonance of an open tube, like in a flute. The acoustic wave in a tube travels through a longitudinal motion at the speed of sound in the air, same 344 meters per second at 21 degrees Celsius, and will change polarity at both ends. Here is one end and here's one end. We can't hear anything here. What is the frequency of the oscillation for a tube of length 30 centimeters? Put in the formula. Yeah, C, the speed of is 2 lengths times divided by T. Namely is the same as 2 lengths. It's one length and a length back is 2 lengths divided by the T. the time it takes is the sound of speed. F is the frequency, is 1 divided by t, and 1 divided by t is c divided by 2l, as you some formulations. T is a period in seconds, c speed of sound, and l is length of the tube. And rho is 1.2 kilo divided per meters in minus third. So rho is 1.2. The air density is 1.2 kilos per cubic meter. You see here, it's good to see the wave is moving, longitudinal wave, and the particles are almost the same place. It's oscillating a little bit in particles, but the wave is moving, a longitudinal wave. Yes. Class measurements. Okay. Some incorrection of resonance tubes. L0 is a physical length. L is effective length. There's a difference between the physical length and the physical length, like here, the blue line here, and the effective length or acoustical length. Because there are some incorrections, one in one side and one in the other side of the hole in the tube, and the incorrection is estimated to 0.3 times diameter. See here, pressure notes in the end, pressure notes at the end here, and pressure notes at the end here of the effective length. That means the pressure is 0. Pressure is positive and goes to maximum, stops here, and then it turns around here, reflected as a minus pressure. And d is the diameter of the tube. Yes. So if you have an open-closed tube, what then? The acoustic wave in a tube travels through a longitudinal motion at the speed of sound in the air. Again is 344 meters per second at 21 degrees. C, the speed of sound depends on the temperature. So it is there is a formula of it. C is proportional to the square root of t. So there's a more special formula in the fundamentals. Yeah. So okay, and will reflect at the closed end with a reversal polarity. Closed end is here. Yeah. What is the frequency f of the oscillation for a tube of length 30 centimeter? Yeah, now it's had to be now it's 4L. Boom. Yeah, it's a quarter. It's one length, a quarter wavelength, and then back on the other direction with negative pressure. There's 2Ls and a half wavelengths, and then it's half length. 2L is the same as half length, so wavelength is 4L. So C is a wavelength divided by the period seconds. And frequency is 1 divided by the period and 1 divided by t. The frequency is c divided by 4L. Again, T is a period in second, C is speed of sound, and L is length of the tube. Okay, now we have to the left an open tube, and to the right an open closed tube. L0 again is the physical length, and L is the effective length or the acoustical length. L is a bigger number than L0, and the end corrections 0.3 times the diameter, and we have pressure nodes in the ends of the effective length of the open tube. So pressure nodes means the pressure is 0, and we have a open closed tube, as it was written here before. The acoustic wave in a tube travels through a longitudinal motion at a speed of sound in the air and will reflect at the closed end with a reversal in polarity. It's here. Polarity in is pressure antinode. Pressure and antinode. That means that is maximum or minimum, you can say. Node is 0 and antinode is maximum or minimum. Yeah. Yeah. And I will just see here. The open tube will change polarity at both ends, and the open closed will change polarity in one end. Yeah. So frequencies of the resonance modes. C is the speed of sound. L is the length of the tube. You can say the effective length with end corrections, and N is a mode, a number of modes. So we have here an open. Pressure is a red one. Motion is a blue one. So pressure is a maximum in the middle, and there's nodes in the ends. Yes. So here we have here N is 1, and here N is 2. Yes, 3 and 4, and so on. Yes, notes. 1 mode, 1, 2 modes, 1, 2, 3 modes, 1, 2, 3, 4 modes. And Fn, the frequency, is n times what's called the wavelengths. No, the frequency. Fn is n times the fundamental frequency. It's n times c divided by 2l for open, and Fn is n times the fundamental frequency is c divided by 4l. But here n is odd. Here for the open closed, n can be 1, 3, 5, and etc. For open, n can be 1, 2, 3, 4, 5, and so etc. Note that notes can be played an open tube tuned in C. Yeah, and we can hear it. Not here in this situation, but on the if you use the notes. And here notes can be played in an open closed tube also. Notes can be played in an open tube and an open closed tube. Yeah. I stop here with the first Aerophone. Listen.